So in this lesson, we'll be going through simultaneous equations. We'll be just revisiting those algebraic skills and really engaging that muscle memory as to how to really always get these marks in algebra and simultaneous equations. So suppose we're asked to solve for x and y in this first equation. We'll be going through multiple equations. So this is the first question where we're given that we have x minus y is equal to 3. That's our first equation, and we're given another equation, xy minus 2y is equal to 0. And we can just label these equations. First equation, equation 1, and the second equation, we just label it equation 2. It's all really up to preference which one you label 1 and 2, but it's always advisable to label them so that you know how to separate them. So from these two equations, we have to construct or create equation 3. And the trick I like really to use is that of the two equations, they all give you an equation where the variable of x and y is 1. So all really look for the simpler equation. For in this case, we can see that in the first equation there's x, right, and there's y, so it's easier to make x or y subject. But in the second equation, we can see there's xy and 2y. So we know that if we were to make either x or y in this second equation, we'll have fractions. So it's easier to go with the first equation, either make x or y subject. So we can just make x subject by saying x is equals to 3, take the y to the other side of the equation, and we'll have plus y. So this will be our equation 3. And now what do? We have to substitute equation 3 into equation 2. So we just say substitute b into 2, which means where there's x, we're going to substitute 3 plus y. Means where there's x in equation 2, we're going to substitute 3 plus y. So we can say 3 plus y multiplied by y, because remember we're only substituting where there's x, minus 2y is equal to 0. If you take note now, what we did now, we only really made sure that there's only y in the equation, so we solve for y. X has been eliminated by substitution. So what we do, we just take the y, multiply the 3, and multiply the y. It'll be 3y. 3 times y is y. 3 times y is y squared. Minus 2y is equal to 0. We have like terms, 3y minus 2y. We can say y squared 3y minus 2y will give us y is equal to 0, and we take out the common factor of y squared. We'll be left with y plus 1 is equal to 0. So our solution for y is equal to 0, or y is equal to negative 1. And then we substitute these values into equation 3. Substitute into y equation 3. Remember, we just calculated our y values, and equation 3 already has x as subject, so we just substitute for y and then we'll calculate what our x is. So in equation 3, what we have is x is equal to 3 plus y. So we can substitute our first value of y is equal to 0. It will be x is equal to 3 plus 0. Therefore, our first x value will be x is equal to 3. And we do the same thing for the second one, which will be x is equal to 3 plus y. X is equal to 3. We substitute our y value, which is negative 1, to be plus negative in brackets, which is the same as 3 minus 1, which will be x is equal to 2. So therefore, our solutions for x will be x is equal to 3 and x is equal to 2. These are the two solutions. So really, to summarize everything, we could say y is equal to 0, x is equals to 3, and x is equals to 3, and y is equals to -1, and x is equals to 2. So these really are the summarized versions of the solutions that we calculated. So let's move on to the next question of simultaneous equations, where we have something more complex than the first one. So in this question, we're given that x plus 3y is equals to 2, and we're given x squared plus 4xy minus 5 is equals to 0. So we can just label this equation 1, and we can label this equation 2. From the two equations, we have to construct equation 3. So as we used the hack in the first question, always look for the variable that looks isolated. In the second equation, we can see there's x squared, there's 4xy, there's 5. There isn't any independent variable or isolated variable. But in this equation, we can see that, oh, there's x, which means we can make really x subject to the formula, because it will be very easy for us. So we can say x is equals to 2 minus 3y. And we can label this equation 3. So we can substitute our equation 3 into equation 2. And you might ask yourself, why don't you substitute equation 3 into 1? We can't do that because it's virtually the same equation. Equation 3 is the same as equation 1, just rearranged. So we substitute it into the equation that we haven't really touched or we haven't used. So it means where there's x in equation 2, you're going to be substituting 2 minus 3y. And there's x over there, and there's x over there. It means this equation will look like 2 minus 3y squared plus 4. Then we substitute our x value, which is 2 minus 3y times y minus 5 is equals to 0. And again, we observe that we are only left with really y values or y variables. So we just solve for y. So here we just expand this bracket to 2 minus 3y. 2 minus 3y. Then here we just FOIL this out. And also note that there's a y on the other side of the bracket. So before we even FOIL that out, we can just write it as 4y. Just bring the y to the side so we don't lose track of that. 2 minus 3y minus 5 equals to 0. So we just multiply 2 by 2 to give us 4. Multiply 2 by -3, -6. Multiply -3y by 2 to give us -6, -6, and -6. Give you -12y. Then multiply -3y by -3y, it will give you positive 9y squared. Then if you fold this out, it will give us 8y. And if you continue, it will give us -12y squared minus 5 equals to 0. So now it might start looking like it's a bit intimidating, and you probably don't know what to do and how to move about the question. So I always advise to really group like terms, right? And I'll probably circle or isolate like terms. There's positive 9y squared, and there's -12y squared. So it's the same as saying 9 minus 12. That will give us -3. But it's -3y squared. And then we go again, so we can simply, to make things easier, we can cancel this so that we no longer use it, or we don't look at the. So we'll look at -12y this time. Is there anything with y? Yes, there is positive 8y. So what you're going to say, you're going to say -12y plus 8 is the same as -12 plus 8. It will give us -4y. And then we move on to the constants. So we can cancel the 12y, the 8. Now we're left with 4 and minus 5. 4 minus 5 give us negative 1 is equals to 0. So we can continue this over there. So we have negative 3y minus 4y minus 1 equals to 0. We can multiply it throughout by negative. We have negative 3y plus 4y plus 1 is equals to 0. Then really we just find the factors of 3 and 1 that will give us positive 4. And that which we multiply will give us 1. So factors of 1 are 1 and 1, and they're all positive. They're positive and positive. So the values for y are 3y plus 1 is equal to 0, which is 3y is equal to negative 1, and we know that y is equal to negative 1 over 3, or y plus 1 is equal to 0, know that y is equal to negative 1. So those are our two y values, and we have to find what our x values are. And to find our x values, we can simply say substitute into equation 3. We can say substitute into 3. And our equation 3, remember we mentioned that x is the subject, which makes it very easy for us. To be x is equals to 2 minus 3 into 1 over 3. And if you punch that into the calculator, you should get an answer of 3. The other solution will be x is equals to 2 minus 3, and the x and the y value is minus 1. And if you calculate that, you should get 5. 2 minus same as a plus, and you should get the value of positive 5. And those will be the two solutions for x and the two solutions really for y. And we would have answered the question. It's pretty lengthy, but it's very, very insightful. I think also the most complicated step would probably be the step over here and the step over there. And really, I'll try to really show you how to use different colors to group the like terms and to not make any mistakes. So we can move on to the next one. So the next exercise is pretty advanced because we're given something that doesn't look like a normal equation. We're given 3x minus 10 is equals to 3 to the power of 3x and y squared plus x is equals to 20. So we can simply label equation 1 and equation 2. So from our equation 1, we can see that we're given two equations, and these exponents have the same base, and if exponents have the same base, we drop the bases and we create the exponents. So we can simply say x minus 10 is equals to 3x, and we can further simplify this by really taking x to the other side of the equation. We'll have minus 10 is equals to 3x minus x, which is the same as minus 10 is equals to 2x, and we can divide both sides by 2x, or rewrite this equation as 2x minus 10. It means x will be equals to negative 5. So actually in essence, we don't even have an equation, we just already have calculated the value of x, meaning that x is equals to 5, and to find the y value, we just substitute this value and say substitute into equation 2. I mean, where there's x, we're going to substitute 5, negative 5. So we can go ahead and do that. We'll see that we will have y squared, where there's x, we substitute negative 5. We just substitute negative 5 is to 20, Therefore, y squared minus 5 is equals to 20. Y squared is equals to 20 plus 5. So y squared will be equals to 25. And if we square root both sides, we'll have y is equals to plus minus the square root of 25. So y will be equals to minus 5, or y will be equals to 5. So those will be our solutions for y. The question may start a little bit intimidating, but it actually played out to be a bit simpler than we thought. And really that will be the summary of simultaneous equations.